Okay, I'm going to work the problems from your homework so that you guys have extra resources before the quiz that you're going to take next class period. So the homework was on page 334, and I'm just going to go in order. So starting with question number 1. And number 1 says the square root of 144, and the directions just say to evaluate it without using a calculator. And most of you guys probably see already that square root of 144 is just 12, and I didn't use a calculator to figure it out, okay? On number 2, we have the cube root of 64. Oops, that's a cube. Okay, and so you're trying to think of some number times itself that equals 64. So if you try 4 times 4 is 16, 16 times 4 is 64, so the cube root of 64 is one single 4. Okay, on number 3, we have the fourth root of 16, and it's a real common mistake to say that that's equal to 4 because you're thinking of square roots, but this is the fourth root, not the square root, so we need some number that multiplies by itself 4 times to give you 16. So if you try 2, that actually works. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2. Okay, I'll go ahead and do number 11 on here before I clear the screen. We have 27 to the 4/3. So if you remember during the classwork in class, I told you guys to deal with the denominator first. So essentially what we have is 27 to the 1/3, and then we'll deal with the 4 later on. So the cube root of 27 is what that's asking for. Remember, 1/3 means cube root. So we can try 3. 3 times 3 is 9, 9 times 3 is 27, so that works. So that means that this guy right here is 3, and then it's saying to the 4th power from here. So we have 3 to the 4th, 3 times 3 times 3 times 3, this is 9, that's 27, and then that's 81. So your answer to this one is 81. Okay, let me clear off the screen. So now number 16, so we've done all of those, it gives us this. And it says to simplify, once again, without using a calculator. So it's basically asking us to do what we did in the first form, just kind of set up differently. So if you consider this square root, you could rewrite it and say 3 squared, 3 squared, 3 squared, 3 squared, 3 squared, 2, 4, 6, 8, 10, 12, 14, and then there's 1 3 left over. So you have 2, 4, 6, 8, 10, 12, 14, 15. So if you take all of those square roots, 1 3 comes out from here. 1 3, 1 3, 1 1, 1, and 1. So we have 1 2 3 4 5 6 7. 7 3s that came out, and then it's square root of 3. Um, 17 is not a problem. Okay, so now if we look at number 19, we have the square root of negative 11 to the 28th power. And because this is a negative, but it's within even exponents, if you think of your even and odd functions, that negative isn't going to make any difference. So we have 11 to the 28th. You can just divide that 28 in half, which is something you can use pretty universally. Just divide the exponent in half when you take the square root, and you get 11 to the 14th, which is your answer. 32, we have 1 plus root 3 times 2 minus root 3. This is almost the difference of squares, but the problem is that that's 1 and that's 2. So I'm just going to go ahead and distribute it all out. So we have 2 minus square root of 3 plus 2 squared roots of 3 minus 3. So I just followed these arcs first and then these second. So now if we combine our like terms, we have 2 minus 3 gives us negative 1. And then this negative root 3 plus 2 root 3 gives you 1 remaining root 3. So that would be your answer there. Okay. So the next problem says 3 root 2 minus 4 root 6 squared. So we can rewrite this to make it a little easier to see. Okay, so I just rewrote it twice because it was squared, so that's what it meant. And then I can distribute. So we have 3 root 2 times 3 root 2 is 9 times 2. And then plus negative 12 root 2 root 6. On the inside we have another negative 12 root 2 root 6. And then the last one is going to be plus 16 times 6. So we can simplify a little bit. Here we have 18, and then these two combine and make it minus 24 root 2 root 6. And then the 16 times 6 is 96. So 96 plus 18 is the last thing we have here. Well, I'm trying to multiply when I'm supposed to add. So 18 and 96 is 114. There. Okay. So now we're at 39. So number 39 looks hairy, but it simplifies pretty nicely. So we have 2 and 11 halves times 2 to the negative 7 times 2 to the negative 5th over 2 cubed times 2 to the 1 half times 2 to the negative 10. Okay, so the first thing I'm going to do is just combine everything so that it's all in the numerator and we don't have to worry about fraction anymore. So we have 2 to the 11 halves times 2 to the negative 7 times 2 to the negative 3, that didn't change. And then times 2 to the negative 3, that's this guy. 2 to the negative 1 half is this guy. And 2 to the positive 10th is this guy. Okay, so now we can just combine our exponents, and since all of these are the same base, we don't have to rewrite that over and over again. We have 11 halves minus 7 minus 3 minus 3 minus 1 half plus 10. Okay, so we're going to start simplifying. Okay, so we have okay, so 11 halves minus 1 half gives us 10 halves. And it's going to be 2 to the 5 minus 3, which is 2 squared, and that should be our answer. Okay, so the next problem will be 39. Whoops. Okay, so the next problem will be 39, and we have so we're on 39 now. So we have 2 to the 11 halves times 2 to the negative 7 times 2 to the negative 5 all over 2 cubed times 2 to the 1 half times 2 to the negative 10. So in this problem, what you want to do is simplify as much as possible. And you notice that all of these 2's are the same base, so that's going to help us to simplify. So I'm going to start by writing them all in the numerator. And so that's what we had before. I haven't changed anything. And then this becomes negative 3 right there. 2 to the negative 1 half changes signs, and then 2 to the positive 10. Okay, so now we see that since they all have the same base, using your laws of exponents, you can just add all the exponents together. Okay, so 2 to the, let's see, 11 halves minus 1 halves is 10 halves. And then all the other stuff stayed the same. And 2 to the 10 halves, of course, is 5. 10 divided by 2 is 5. So now we can add these together, and we have 5 minus 5 cancels out. Negative 7 and negative 3 make negative 10, and then positive 10 makes 0, so we end up with 2 to the 0 power, which is 1. Okay, so 41 is the next problem that we want to look at. And for 41, we have the square root of 16, a to the 8th, b to the negative 2. Okay, and this is pretty straightforward. We're taking the square root. So the square root of 16 is 4. Square root of a to the 8th would just be a to the 4th. I divided by 2. And then b to the negative 2 would become b to the negative 1 because you divide it. And then that would be your answer. Okay, number 44, we have this expression, a to the negative 10, b to the negative 12, over a to the 14th, and d to the negative 4. Okay, so we can simplify this first of all into a single square root. So that gives us a to the negative 10, b to the negative 12, over a to the 14th, d to the negative 4, and that's all one square root. Okay, we can put it all into the numerator. We have we have a to the negative 10, b to the negative 12, a to the negative 14 because I moved it up so it becomes negative, and d now is to the positive 4. So then we can just simplify the a's here. We end up with a to the negative 24, b negative 12, d 4. What did I do? Okay, so now number 44, we have square root of a negative 10, b negative 12, over square root of a to the 14th, d negative 4. So the first thing we can do is combine these all into a single square root. So we have a negative 10, b negative 12, over a 14, d negative 4. And first thing we notice is that our a's are going to simplify, except because that's negative and this is positive, they're not actually going to simplify all that straightforward. So let me go ahead first and write them as a single numerator without the denominator. So we have a negative 10, a negative 14, it changes signs because it went up, b negative 12, d negative 4, and that's all square rooted. So when we combine stuff, we get a to the negative 24, b negative 12, d negative 4. And then we're taking the square root of that, which means we're going to have a to the negative 12, b negative 6, d negative 2. And that would be our answer. Okay, so we are now on 44. So we have, for that problem, a negative 10, b negative 12, all over a to the 14th, d negative 4. Okay. First thing we're going to do is combine into a single square root. So we have a negative 10, b negative 12, a 14, d negative 4. And then we want to write this as a single thing, not with the fraction there. So I'm going to put everything in the numerator. The first terms stay the same, a to the negative 10, b to the negative 12, and then we want to move all of these upstairs. So to accomplish that, both the exponents need to change signs. So we get a negative 14, and then d now is positive 4. So if we simplify that, we have a to the negative 24, b negative 12, and d 4. And that would be about as simplified as you're going to get it. Or I'm sorry, this b, sorry, this is still a square root. I forgot about the square root. So once we take the square root, we get a to the negative 12, b to the negative 6, d squared. And then that's as simplified as you can go. Okay, so let's clear off the screen, and we'll now do 45. So for 45, we have 4x plus 2y to the 18th, and that's all the 9th root. And so, again, if you want to think about this as a rational exponent, we have 4x plus 2y to the 18 over 9. Remember, this side, or this number goes on top, this number goes on bottom. And so when you reduce that, you get 4x plus 2y squared. And so that would be your answer to that one. Okay. Let's look at 49. We have c to the 2/5, d to the negative 2/3, and then c to the 6, d cubed, and it's also 4/3 power. Okay, so first thing we want to do is take care of that 4/3. So I'm going to rewrite this other part. So this would be, here it'd be 6 over 1 times 4 over 3, so those cancel and that gives you 2, so that'd be 8. Okay, and then the same thing for d, we have 3 over 1 times 4 over 3, those two would have canceled, we would have had 4. Okay, and now we can just combine our bases. These two are going to go together, so we have c to the 2/3 plus 8. And these two will also never get together, or will get together. So we have negative 2/3 plus 4. So you could then simplify this. We need common denominator, so c to the 2/3 plus 24/3. And then the same thing with the other guy. Okay, so here we get 26/3. And here we get 10/3. And that's the answer. Okay, so let's clear off the screen and go to 55. So for 55, we have a to the x squared, and that's all raised to the 1 over x power. Okay, so if we go ahead and take care of this exponent, we have a to the x squared over x, which if you simplify gives you a to the x. And that's our answer. 57. we have the cube root of a squared plus b squared, and all it wants us to do is write it with the rational exponents. So this one would be a squared plus b squared to the 1/3 power. And that's it. Okay. How about 60? We have the square root of the cube root, and then a cubed b to the 4th. Okay, so let's first of all get rid of this inside square root. So we have a cubed b to the 4th, and that's to the 1/3 power. And then all of that is to the 1/2 power. So if we simplify this a little bit, we have a cubed b to the 4th times 1/6. And then we can further simplify them like this. So I just pulled in that 6 to be part of the fraction. So a to the 3/6 is the same as a to the 1/2, and b to the 4/6 is the same as 2/3. So that would be my answer. Okay. Number 73. We're just rationalizing the denominator. So this first one is 3 over square root of 8. We don't want this 8 to be down there, so we're going to multiply by root 8. So we end up with getting 3 root 8 in the denominator over 8, because it was 8 years of service. And so that should... Why am I saying weird things, Mom? Okay, so now let's look at 73. And on 73, we're just rationalizing the denominator. So we're going to be multiplying by square root of 8 over square root of 8. So in the numerator, you get 3 root 8. In the denominator, root 8 times root 8 is positive 8, and so you can stop there, and that would be your answer. Or actually, you want to simplify this, because root 8 you could simplify. So it'd be 2 root 2. This would be root 8 over 8, and so it would be 6 times square root of 2 over 8. You could simplify this more and say that's 3, that's 4, and so your final answer would be 3 root 2 over 4. Okay, 76, we have 1 plus root 3 over 5 plus root 10. I'm going to multiply by the opposite of the denominator, so it's 5 minus root 10 over 5 minus root 10. So in the top, for right now I'm just going to leave it like that. Okay, and then in the denominator, you have 25 minus 10. Okay, so now if you wanted to actually distribute this like you normally would, we have 5 minus root 10 plus 5 root 3 minus root 30, and then at 25 minus 10 would be 15, so you would have that. But that's not a very nice and simplified answer, so it might be better just to stick with this before the FOIL. Okay, and then we'll now do the last problem, number 77. So 77 says 2 over square root of x Okay, so square root of x plus 2. So again, we want to get rid of this square root. So we're multiplying by the negative of that. So negative x, square root of x plus 2, this sign stays the same. Okay, and okay, last problem, number 77. We have 2 over square root of x plus 2. This is what we're trying to get rid of, so we're going to make it negative. So we're multiplying by negative root x plus 2 over negative root x plus 2. So in the numerator, we just have this. And then in the denominator, it's essentially the difference of squares. This would be 2 minus root x, and this is 2 plus root x. So you have 4 minus x. so that would be your answer to that.